So after we imported the HAZOP inside SafeGuard Profiler, what is the next step? So now we are ready for SIL determination or running these methodologies in order to find out whether we need a safety interventive function or not. So what is SIL determination? SIL determination is to determine or to ascertain the amount of risk an industrial process has or will require in order to reduce the probability of a harmful event from happening. So that would be to recreate the hazardous scenario or complement it with all those HAZOP scenarios that were described before in during the HAZOP session. Now we're regroup them in a specific or in a methodological way according to certain criteria in order to ascertain that amount of risk that is in those scenarios and reduce it accordingly. So in this procedure, in this process that we go through each scenario by scenario, we might find that we need an additional safeguard in order to reduce risk to a tolerable level. So we will know later on what that tolerable level is and how do we get that number. And the way that to reduce risk if it is needed, because there's a risk gap, then we will cover that gap with the safety interventive function, which is a special safeguard. It's a safeguard that we have the ability to engineer and design to match the target risk or better. SafeGuard Profiler is a software tool that allows to determine the amount of risk reduction required to lower that risk and to bring that risk to a tolerable level. SafeGuard Profiler provides you with two methodologies. One is called the risk graph and the other one is called layer protection analysis, LOPA. So those two methodologies are available in order to work further with SafeGuard Profiler. After we have the HAZOP import, we'll talk about layer protection analysis. We will go through the nodes in the HAZOP and all those scenarios in each that are in the nodes, and we will search for consequences, for the same consequences, right? And we call the SIL ready HAZOP is a HAZOP that already has a column which has a mark saying yes, no. Yes would be if that scenario qualifies as a candidate to go through further study because either that scenario is too complex or the risk is too high, or other criteria that we will discuss later on. So first we go through the HAZOP, we search for those scenarios that have something in common, which is the same consequence, and also they are related to each other because they are in the same area or they are in the same process unit. So we will go through the HAZOP that is already imported in the SafeGuard Profiler and look for those commonalities. That will allow us to create this layer protection analysis scenarios. And after we create those scenarios, maybe they might have a combination of more than one HAZOP scenario, depending on this criteria that I talked before. So now we can identify all initiated events or causes. Then we identify the protection layers to mitigate the consequence. Identify meaning that they were already put in the HAZOP, but we just verify very quickly the place with respect to the cause that is reducing the risk for that cause. Later, number 4 will be to confirm the frequency for each initiated event. So that means that we already have certain assumptions with us, and those assumptions contain statistical data from equipment that is being used in that facility, or if there's a facility that hasn't been built yet, it will be generic data coming from facilities that are built and that already have that amount of data that is useful from statistical purposes to tell us, well, how often things break or what is the frequency of those initiated events that if they happen will end up and in an unwanted event. So we confirm those frequencies with the team, and then the next step would be to confirm that the probability of failure on demand of each safeguard that was assigned or that works against that cause. That means that we'll either stop that cause or mitigate that unwanted event and mitigate it from the point of view of protecting the target, not letting the target to be reached. So we confirm those probabilities of failure on demand just in the same way that we got this assumptions of likelihoods, we will have these assumptions for probabilities of failure on demand. And these assumptions, of course, are assumptions, and they have to be verified and validated during the session. So you cannot just copy from this pre-worked information or data and just use it just like that. Each one has to be confirmed, and the team has to discuss to see if it makes sense or not. And that's what is called an engineering evaluation of that information. Don't just take them and put them in there. So discuss about and intelligently about those numbers that you're getting and what they mean specifically. So now we identified non-independent protection layer factors for risk reduction. So those are other factors or other protection layers, right? They would be, for example, process safety valves, or they could be other trips coming from the basic process control system, coming from a PLC, coming from an independent sensor and actuator, from other places that they are not really safety implemented functions. So, and that's what we call all the other safeguards, right? So we identify those other safeguards that are not safety implemented functions. Identify where more precise numbers are required. So that means we go back after having more information about the scenario layer protection analysis scenarios that we have studied. So we go back and again reconfirm and make sure that yes, the numbers that we picked make sense after discussing and getting more information. And then if we have to adjust those numbers and put more precise numbers, then we'll do that at that moment. Then we go and determine the sum of mitigated frequencies. That means that sometimes on layer protection analysis scenario contains more than one HACCP scenario. And the commonality between them is that they all lead to the same consequence, the same severity, and they are all in the same area or the same unit, right? So that commonality, that means there is risk coming at you from different deviations, different causes, and they all have to be summed up, right? So here we sum all those sources of risk because we have to mitigate or reduce that risk if it is too much. So we sum all these mitigated frequencies, and then finally we compare the total tolerable frequency, we divide that by the total mitigated frequency, and then if there's any gap we will see it there as a number that is not 1. So TF divided by MF has to equal 1. And at the end, if we find out that the TF divided by MF does not equal 1, it is a number less than 1, that means that we assume that that number will be required, that the number that is there will be interpreted as being a safeguard, and that safeguard, that would be the probability of failure on demand of that safeguard. So if TF over MF equals 0.1, that would require a safety implemented function with a target of 0.1. This is what happens after we import the HACCP. If we decide to go and use layer protection analysis as a methodology to find out whether we need more safeguards or not in order to reduce risk to a tolerable level. Making a recapitulation, so LOPA uses initiated events and expresses them in terms of event frequencies or likelihoods. Then we need a tolerable frequency number target. It is required from the company. Same stakeholders of the company that created the risk metrics, they will give us the tolerable frequency target for that specific risk that we are analyzing. For example, risk with respect to health and safety. What is the risk of loss of life? That has a specific tolerance from the point of view of the owners of the company. Then we determine how many or how robust each protection layer has to be. That's layer protection analysis. You analyze the integrity of those safeguards, whether they are independent or not, whether they are dependable or not. Then we determine if the tolerable frequency is met. That means TF, tolerable frequency, divided by the mitigated frequency, MF, equals to 1. Then we use a specific cause frequencies. We use a specific independent protection layers, probabilities of failures on demand, and we'll look a little bit more in detail on what that means. So one important thing about this methodology of layer protection analysis means is that we can assess multiple causes with the same consequence, with all of them being contributing certain amount of risk. All those deviations and scenarios might be some of them. There are all of them have in common be having the same severity of the consequence, and all of them affecting that risk receptor at that moment. So we can assign a specific PFD to a safety implemented function. That's what I said before. If you have TF over MF and their number is less than 1, well, that number is interpreted as being the probability of failure on demand of that safety implemented function. That means can assign a specific PFD value to a safety implemented function. So this comes directly from the IEC 61511 part 3. They show there a table, and that table represents, you can build this table, for example, in an Excel spreadsheet, and in there you will see all these columns, and this will be putting into order the initiated events or the causes, and then putting the protection layers, as you can see here, and then putting other modifiers sometimes, or conditional modifiers and enablers, so that they will work out into the LOPA scenario. So we can have it either this way, building up in an Excel or a spreadsheet, or we can use SafeGuard Profiler, which is a much better tool, because you don't have to deal with this Excel spreadsheets. You don't have to build them. You don't have to construct them. All is already made for us in their own SafeGuard Profiler, and it is using the advantage of graphically showing what does the scenario look like, instead of trying to have an image in your head and extracting these numbers from rows and columns. It's kind of complicated. Sometimes you get lost dealing with these Excel spreadsheets. So it's maybe if you have a software tool that allows you to graphically represent and to better concentrate on the process from the process point of view, instead of the technicality of looking inside a worksheet. For the other methodology, which is the risk graph, extracted from the risk metrics. So we have to talk a little bit about the risk metrics. What is the risk metrics? So every company that has a management strategy with respect to risk has a risk metrics, and the risk metrics allows facilities to measure the level of risk. So it's a tool that allows you to measure how much risk do you have for a specific situation. And we will talk more about what risk means. Your risk metrics has one axis that is the frequency, and those frequencies have linguistics assigned to them, and we talk about frequent, probable, remote, improbable, highly improbable, and they go with respect to a time frame period, right? So if it is 1 in 10 years, or if it happens at least between once in a year or more, then you might say that is a frequent event that is happening. And then on the other side of the axis, we have the severity, and the severity of the consequences. So you have, for example, if we were talking about health and safety, we see that the severity, lowest severity, is just a first aid administered to someone that got caught or that got burned, with not serious burns and so on. But if that person gets an injury that needs a doctor appointment, and so he might have to go home, and he will lose time of work, so he will not be able to come to work the next day. Well, that's a lost time incident, and so on. So the severities are also ranked according to descriptions that you have in there. So each company has to make their best effort in describing, so that people, when they're analyzing the scenarios, they can really find out where are you at that moment. What does that mean? Do you have a high risk or a low risk, and so on. So that's why this risk graph or the risk matrix is built by the stakeholders of the company. After we have that and we understood that, we can look at something called the safety layer matrix, and that safety layer matrix is a way to determine the amount of risk that we have at a certain moment, and whether that risk is too high and needs some safety implemented function to lower that risk. So this is a graphical way to do an analysis and to determine whether we need a safety implemented function with a specific target, a safety integrity level, a specific SIL number. You can see here minor, serious, extensive. That would be with respect to the severity of the consequence, right? And then we will have the frequency, how often it happens, right? And according to that, risk is in function of probabilities or likelihoods with respect to how bad the consequences on how severe the consequences are. Right, so this is in principle what we're doing here. So risk graph or your risk metrics should have a very well describe or should very well describe situations or describe this linguistics that we use. For example, what does low means, right? Low is a relative word. What does medium means? What does high mean? What extensive, serious, minor, all that has to be very well explained. So that's for example, if we take serious consequence, what does that mean with respect to equipment? So damage to equipment, shutdown of the process, serious with respect to health and safety would be serious injury to personnel, and the environment if it is environmental. So you see, you describe very well what serious mean with respect to each category of risk that we will be analyzing, and so on. So this is certain point of view. Companies should spend enough time to make descriptions that are not ambiguous, and the descriptions that can help people make decisions with respect to scenarios that present during these sessions of hazard and operability studies and layer protection analysis. So we're going to look at very quickly at what risk graph method is, and this is also offered inside SafeGuard Profiler. So we have this other methodology, and you can see here a calibrated risk graph inside, and this is an extract of the original risk metrics. So don't copy from a book, that's not good, right? So each graph is going to be calibrated according to what that risk metrics you have, right? And then you extract that information from there, and there are high risks, or there are places that you might need some specific safety instrumented functions. And so the risk graph, the point of departure means if after looking at the scenario without adding any safeguards at all, what would be the one safeguard, how good it has to be in order to lower the risk to a tolerable level, right? So that would tell me, for example, here the W ones means the likelihood, how likely it is, and that is represented by the axis of the risk metrics of probability or likelihood. And then you see I don't have W4, W5 if there is a 4 by 4 matrix or a 5 by 5. Right? I only extract portion of the risk metrics. There is a place that needs a safety implemented function. Well, that's the place that I'm going to extract from that risk metrics. The W1, 2, 3, that will be the point of entrance to start analyzing the situation or the scenario, right? So first of all, no safeguards are in there, and I'm looking whether one safeguard, which is called the safety implemented function, how good it has to be in order to reduce risk to a tolerable level. So you can see that indirectly we have a tolerable zone in our risk metrics, and we have to drive from the high risk to the tolerable risk place. So the first part would be to look for the likelihood, and this case is W2, that means a low between 1 and 10 years, or once per year. So that's one definition that this company decided to pick. So we start in there, and then we start asking other questions at the team, right? So for example, for the consequence point of view, is it a slightly injury? Is it a serious injury, one death? Are there multiple deaths? Is it a catastrophic, more than 5 people getting hurt? So then that would be the point of entrance into the risk metrics and start making decisions. So point of entrance C1, C2, C3, right? So in this case we'll say, well, it's C2 for that specific scenario, Then we ask the next question. Next question would be exposure. This will be a conditional modifier, meaning is someone in there, is the target present in the space, in the location, in the unit. If it is present, for how long? So that means exposure. That exposure of that target being vulnerable to get reached by the harm released by that unwanted event, right? So that's the second question that we ask. So is it rare or frequent? So we take a decision in this case, well, it's just rare. What that means, well, people don't often go to that place. Recognizing maybe there is a hazardous place, well, don't go there. So try to restrict the amount of people that have to be there. So necessarily be there, for example, would be some people that have to do maintenance or some rounds. And you count those in hours. So for how long people are in those places, and you say, well, during the period of 1 year, how often or how much time is that person exposed? Right, so you start counting. Okay, he's there for 2 hours every day. Someone is there for 2 hours every day. So you count. There are 24 hours. There are 8,760 hours in a year. So how many those 2 hours times 20 times how many days there is in a month? 30. 2 times 30. So that means 2 hours per day during a month, and then times 12. And you get the amount of hours expend during a year. So and then at the end you'd say, well, what is the percentage? Is it 10%? Usually it will not give you exactly 10%. It will give you 7%, 5%, and so on. So you put sometimes you round that up into the safe place. So you say, well, 10% of the time. And so that would be the answer to that F2. Then P, possibility of avoidance. What does that mean? So is it possible to escape? Is it or not likely if the unwanted event happens? Is it possible for the target to escape? So then yes or no. So if it is no, then we have our W2, that is the frequency or the likelihood. So we end up with the ones. If this risk graph is well calibrated, we will have specifically, we would need a safety implemented function with the SIL level of 1. And that's a very big range, a SIL 1, right? And we will talk more about it, but that's the methodology. That's what is the methodology for risk graph, and to find out whether you need a safety implemented function or not. After you find out that there was some risk in there, and in order to cover that risk you might need a safety implemented function, you start asking yourself, well, is it there already there some safeguard in there? Is it there some administrative procedure already in place? Is there already a trip from the basic process control system or from the DCS that is independent? So if it is there, I'd much rather take that and take a risk reduction of 10 instead of adding maybe a safety implemented function with the SIL level 1. So those are the decisions, and that's what happens pretty much in the sessions, and this would be one of those methodologies that SafeGuard Profiles offers for you.